Okay, I'm going to talk about the direct product of two groups. Suppose we've got a group G and a group H. I'm going to write it with a little circle for the operation, and I'm going to write that with a cross, let's say. Actually, I'll write it with a star. And what I'm going to do is to form this ordered pairs GH, where G is a member of the set G here, H is a member of the set capital H there. And I want to multiply these together. And you write it like this. That's the general form, G sort of cross H. And you sometimes see, well, you see this notation here, if G and H are abelian. Guess that should be abelian like that. Okay, so it's G cross H. It's just a direct product, and it's done in a very simple way. We need to define a multiplication, so G1 comma H1 multiplied by G2 comma H2, where G1 and G2 are in G, that should be a sort of G, and H1, H2 are in H. And you just multiply those component wise, G1, G2, comma H1, H2. It inherits its associativity from the associativity of G and H, and basically it just works as you expect it to work. It's got an identity. Well, what's the identity? The identity, I guess, is EG comma EH. It's the ordered pair of the identity in both groups. So I'll just give you one. Well, I'll give you the simplest non-trivial example: C2 cross C2, where C2 is addition modulo 2. So the operation looks like this: 0, 1, 0, 1, odd and even basically. So C2 cross C2 is going to be ordered pairs of x comma y, where x is a member of the set 0, 1, and y is a member of the set 0, 1. So the elements are going to be 0, 0, 0, 1, 1, 0 and 1, 1. These are the elements of C2 cross C2. There they are. So I'm going to write them out like that. Oh no, it's 0, 0 to begin with. 0, 1, 1, 0, 1, 1. And down here 0, 0, 0, 1, 1, 0, 1, 1. So you just do them element wise, really. 0, 0, 0, 1, 1, 0, 1, 1. I can fill in the first row really easily because this thing here is the identity. As that is there, so it's a right identity and a left identity, so fill it in there. To do this one, 0 combined with 0 is just 0, and 1 combined with 1 is just 0. So that's easy. 0, 1 with 1, 0 is 1, 1. You see, I'm just doing the first. To do this one, I'll just do the first one, which is 0 with 1 is 1. And the second one is the second of that with the second of that, which is 1 and 0, which is 1. Because odd plus even is odd, I guess. What's this one? 1, 1, 0, 0, 0, 1, 1, 0. That's 0, 0. I guess you could call it exclusive OR as well. And what's that one? 0, 1. So there we have it. I'm going to relabel them A, B, C and D, and just because it might be a nicer and more easily recognizable group table, A, B, C, D. There's my operation. A, B, C, D, B, C, D. Actually, looking at this one, 0, 0 is the identity. And you'll see from this picture here that the main diagonal down here has got the identity. Well, of course it has, because it doesn't matter what your numbers are. If you do addition modulo 2 with a number with itself, you get to 0. So this is 0. So the identity is on the main diagonal, so I can just write that in, because A is the identity here. What else can I do? Can I say anything intelligent about this? Oh, look, that symbol matches that one, so that must be a D, because these guys tally, and those guys tally there. Can we say anything else? Yes, look, that one must be a B, because in this column here we need one of each letter. That one must be a B as well. It's like Sudoku. That must be a B as well, I guess, because this row now is CB. Oh no, that's a B. That's not right. Try and rub that out. That must be a D, not a B. And that one must be a C. There we go. So that's C2 cross C2, which is sometimes called a Wehrgruppe, and I'm probably going to spell it wrong, but I think it's Wehrgruppe. For group. While I'm talking about that, I'm just going to write another one down. 0, 1, 2, 3. This is addition modulo 4. Two, 3, 0, 1, 3, 0, 1, 2. All that is addition modulo 4. So for example, 3 plus 3 is 6, which is 2 modulo 4. You'll see that this, I'm going to change colour here, I'm just going to change it to old blue. This one's got sort of stripes going down here of constant values. And you don't get that same pattern turning up here at all. So they're different groups. And there's no way you can rearrange these guys here to have this phenomenon occurring. Well, there's also an interesting observation, which is what in this group here, 1 to the power 4 equals 1. So the order of 1 is 4, and there's no element here of order 4. So they're not isomorphic, they're not the same group. So there's two distinct groups of order 4. Okay, I'm going to stop there.